All right, so we're going to learn about three operations in this thought primer. The operations of conversion, obversion, and contraposition. And I'm guessing these are three really new words and concepts for you. So you're going to want to make sure as you work through your lectures that you take really good notes and that you reach out to me with any questions you have or anything you want clarified. It's also really important that, as always, you pause your video when I ask you to and work on the problem that I'm presenting you with, because that's how you're going to learn how to use these operations correctly and to understand what they mean. All right, so let's get started by thinking about what it means to say that two statements are equivalent to one another, or some group of statements are equivalent to one another. When we talk about statements being equivalent, what we're really saying is that these statements express the exact same information. They have the exact same meaning. It's not that they're close in meaning or that they're similar. They are expressing the exact same information, and as a consequence of that, they have the exact same truth values. Okay, you can't have two statements that say the same thing and have one statement be false and one statement be true. If one of them is false, they both have to be false. If one of them is true, they both have to be true, because they are equivalent to one another. So you take a statement like this: no cats or dogs, and another statement: no dogs or cats. And you ask yourself, are these two statements expressing the exact same information? Do they have the exact same meaning? What do you think? To answer the question, the easiest and most effective and really definitive way is to create a Venn diagram for just one of the statements. Okay, so maybe I create a Venn diagram for the statement no cats or dogs, and I complete that Venn diagram by shading in area 2 because I want to show that there are no cats that are dogs, and if there were any cats that were dogs, they would be right here in area 2, but there are no cats that are dogs, so I turn out the lights because nobody's there. Now I look at the second statement. Does this one Venn diagram also show the statement no dogs or cats? And the answer is yeah, it does. Because if there were any dogs that were cats, they'd be right here in area 2, but area 2 is shaded in. So we can demonstrate with this Venn diagram that these two statements, even though the wording is a little different, right? The order of the words is different, they express the exact same information. They have the exact same meaning. So if one of them is true, the other is also true. If one is false, the other is also false. Now we're going to play a game. You're going to see if you can recognize a pattern here. You've got four sets of statements here, okay, or four pairs of statements. And what I want to know from you is how many of these pairs are equivalent statements. Okay, so what I want you to do is go ahead and pause your video and then draw one Venn diagram for each pair of statements. And after you have drawn your Venn diagram for, say, the first statement in each pair, look at that diagram and see if it also reflects the second statement in the pair. And when you're ready to check your work, you know what to do. All right, how many pairs of equivalent statements are there here? Did I hear you say 2? Wow, you're a genius. All right. Yeah, there were exactly two pairs of statements. Is that the right way to say that? That are equivalent to one another. No cats are mammals and no mammals are cats. That Venn diagram looks just like the one we did earlier with the no cats or dogs. And the statements some cats are mammals and some mammals are cats also are both reflected by this one Venn diagram. So we can say that these pairs of statements are equivalent statements. Now, when you look at your other pairs, we see, no. These statements are not both reflected by a single Venn diagram. When I diagram in all cats are mammals, I shade in area 1 because that would be an area where there would be cats that weren't mammals, and I want to show that all cats are mammals. But after I do that, I don't see the statement all mammals are cats because there could be some mammals right over here in area 3. Area 3 still got the lights on, so maybe there's something there. Same thing down here with this pair of O statements. When I want to show some cats are not mammals, I got to mark an X somewhere over here in area 1. And when I do that, I do not see in this Venn diagram the second statement in the pair, some mammals are not cats, because I don't know over here if there's mammals in area 2, area 3, or both. So I don't know if some mammals are not cats. I don't know if there's anything here in area 3. Maybe it turns out they're all in area 2. And remember, we're not asking ourselves whether or not the statement is actually true. We're just diagramming the statements as if we're assuming they're true. And so when we diagram this false statement, some cats are not mammals, we're assuming it's true, and that gets us to put the X over here. Now, I know that there are some mammals that are not cats. So I know this second statement is also true, but it's not reflected by this Venn diagram. And because it's not reflected in this Venn diagram, that tells me these two statements are not equivalent. All right? So what exactly is going on here? Well, we're going to start to answer that question in the next lecture.